Hi, welcome back. What I would like to go over with you in this third video from vectors is some of the properties that vectors must follow. Now, vectors have to follow most algebraic properties. For one, they have to follow the commutative property, which means we can add vectors in any order. Property two, that's the associative property. If I take two vectors and add them, and then add a third vector, I can change the order in which I add them. I can rewrite them in any number of ways. In other words, I can add them in any different order. That's the associative property says. We can add in any order. For example, if I take 1 plus 2 plus 3, that's the same as if I did 3 plus 1 plus 2. We can associate them in different orders. The third property of vectors is the identity property of addition. If we take a vector, add that to what we call the zero vector, that's going to give us the original vector back. That's the identity property from Algebra 1. Also, they have to follow the inverses. If I take vector A and I add negative A to it, we're going to get the zero vector. It's like saying 5 minus 5 is 0. The zero vector is just 0. This is what we call the inverse property. And all that says, algebraically, we can use it to solve equations too. The inverse property. A fifth property, again, is very similar to the associative property. If I have A and I can multiply B times vector C. Now be very careful here. Only C is the vector. A and B are scalars. I can multiply in any order. I can take A times B, multiply that by vector C. Now be very careful. A and B are scalars in this example right here. So we can just multiply your scalars together and then distribute that to the vector itself. Another property that they have to follow, if I take two scalars, C plus B, multiply that by vector A, I can distribute vector A, AC plus A times B. I can distribute. Likewise, if I have two vectors that are being added together, and I'm multiplying that by some constant C, I can distribute that. C vector A plus C times, oops, sorry, that's not a vector. C times vector B. Eighth one. Then again, these are all properties that we know from Algebra 1. If I take 1 times it by a vector, that's just going to be vector A. This is the identity property of multiplication. Where up here was the identity of addition. And what if I take a vector and multiply it by 0? What would be 0 times the vector A? Well, that's just going to give up, sorry, not A. That's going to give us the 0 vector. And that's our zero product property. Anything times 0 is 0. That's from Algebra 1. Now, what is the 0 vector, you might ask? Well, the 0 vector is just defined as 0, 0. My change in x is 0, my change in y is 0. We just haven't moved at all. And you're going to hear a thing called what's called a vector space. Now, all the vector spaces, this is just a set of vectors on a plane. Remember from geometry, planes is a flat surface. So, for example, here's vector A, here is vector B. And we can incorporate this into multiple dimensions too, in 3D as well. Now, the one thing we haven't talked about yet is, well, how do we multiply two vectors together? What if I want to take vector A times vector B? What's that going to equal? We're going to talk about that in a couple of days. I hope you guys have enjoyed the video. I will see you.